Yeah, now it's recording. Jeez. Sorry. All right. The software. It's good, and they give it to us for free, but test my patience some days. All right. So thank you for that. So we don't have to write this equation as W equal to the rest of it. We just have to use our root finding method to help us find W such that this zero equation is equal to 0 at the end of the day. Yes, sir?
So in the problem, you have like a lowercase a equals elevation of ladder, lowercase b equals the other ladder. So would that be your two input arguments then? And then you have another equation that solves for the capitals, or?
So little a and little b are just to label the diagram. You're not actually using those in the equations. You're given the length of that. Big A is 40 feet, big B is 60 feet, and then H is 10 feet, and then you have to solve for W. That's what we don't know. So when we're writing zero equations, we have kind of two forms of things. We either have a desired value, like we did in the skydiver problem, or we have some equation where I'll say we need to find the root such that it satisfies that equation, and then we follow this format for the ladder problem. Questions about that? All right. So one more kind of thing I wanted to talk about. So I'm going to erase this stuff. So we're doing root finding. We have two different kind of levels of things going on. We have root finding methods, and then we have problems that we're trying to solve. So we have kind of two different things going on. So we have root finding methods. And we've learned about the bisection method. That's a root finding method. And on your homework, I ask you to do the false position method. That's another root finding method. Did you say it sucks? It's not that bad. And then there are, I don't know, probably 50 more root finding methods. We're not going to talk about all those different types of root finding methods, but there are lots and lots of other root finding methods. We also have problems that we're trying to solve. So we have problems. We've done the skydiver problem, the ladder problem, the cable problem on your homework. What's the other program? The Reynolds number problem on your homework. Lots of different problems that we can try to find roots for. We can use any root finding method to solve any one of these problems. So on your, in our example, kind of in the next class exercise, we use the bisection method to solve the skydiver problem. That helped us find the math value that we were looking for. We also can use our bisection method to solve the ladder problem and find the root in the ladder problem W. We can also use the bisection method to solve the cable problem, and we can use the bisection method to solve the Reynolds number problem. Any root finding method can be applied to any problem that we want to try to find a root in. So the same thing with the false position method. We could use false position to solve the skydiver problem. We could use false position to solve the ladder problem. We could use false position to solve the cable problem. And we could use false position to solve the Reynolds number problem. So we can, this is like the two different levels of things that we have going on. Whenever we're doing root finding, we've got either a method to pick, or we have a problem to solve. And we've got to write the code for both of those things. So you're going to have one function that has your root finding method in it, one function that has your problem in it, written in the zero equation form. And that's, at minimum, what you're going to need to solve any root finding problem. So, and these root finding methods kind of all follow the same pattern. The big difference between them is just kind of the method that it uses to find the root. The problems, we write all basically in the same way. We have to form a zero equation. We follow kind of those two kind of formats that we set out at the beginning of class, and that's how you write zero equations for a lot of different things. Question?
Yeah, I was just thinking about the difference between the two methods. It's just like the xn, the x3, am I right?
Right, so between the bisection method and the false position method, there's really just one equation that's kind of different between the two. Other root finding methods may be a little bit more different, but we're not going to talk about those.
Okay, the other question, like, if I have a zero like file for each problem, so
Yep.
I can run it for any one of them. Just I need to change the name of the function that I'm gonna run. Am I right?
Yes, yes. So if you want to run your bisection method for the skydiver problem or the ladder problem or any other problem that we have, we just have to make sure that in our bisection method function code, we're using the right zero function. We're using the skydiver zero or the ladder zero or blah, 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 whatever zero function it is that we want to try to use. So questions about that? Does that help clear things up in people's minds, kind of what's happening, some of these things? Let's see, I was going to say one more thing about, we'll do it later. Think about it. So on your homework problems and on your in-class exercise number 2, I ask a couple questions. I say, how would you get your initial guesses for the root finding method? So how many initial guesses do we need to provide our bisection method? 1, 2, 15? 2. So how do we get those 2 initial guesses? Should we pick random numbers? Probably not. Where can we get good educated guesses for our initial guesses?
From the
a plot. So what do we want to plot in that case? Do I want to plot my original equation or do I want to plot my zero equation? The zero equation. And why do I want to plot the zero equation? Just because it makes my life easier. So if I plot my zero equation, I'm going to get a plot. It's going to have what value goes on my x-axis of this plot? W. So it's always going to be the variable that we're trying to solve for, or our root that we're trying to solve for. That's what goes on our x-axis. We generate a bunch of W values using linspace or colon operator, whatever we feel like. And then what's going to go in our y-axis here?
edge.
Not quite H. It's going to be, so in MATLAB, we can't say 0 is equal to this, right? I can't type that into MATLAB. I'm going to have to give this some sort of variable name. Maybe I call it 0 or H0 or whatever you want to call it. And that's the value I'm going to plot on my y-axis. So my function, I can't remember what the ladder problem function looks like, but if I were to plot it, it might look something like this. And where is my root?
It's in the point that crosses the...
It's the point where the function crosses the x-axis. So this is going to tell me my root, which is W that satisfies the zero equation. So wherever that root is, that tells me a value of W that makes this equation, the right-hand side, equal to the left-hand side. That's what my root is. So when I pick initial guesses, where do I want to pick initial guesses? Should I pick these over here? Those good or bad initial guesses? Bad. Why are they bad? We need one on either side of our root, right? So I can get rid of one of these and I gotta pick one over here. Same thing, I can't have two initial guesses over on this hand side, right? So I get from my plot kind of just a general idea of one, where my root is, two, where I should pick my initial guesses. So the plots are helpful for picking initial guesses. They're also helpful for just kind of making sure that we're in the right ballpark with our root. If the root we get from our root finding method is not approximately this W value, we know we've done something wrong. Any questions about that? All right, what about the second question? How would we check to see we got the correct value of the root W? And I said, hint, if you ran your zero equation function with the solution for the root W, what should the error be? Should be 0, right? So how would I do that? So I take my root, whatever it is, 30 something or other, that the root finding method gives me, and I plug it into what function that I have? The zero function. I plug it in my zero function. The answer that I should get back should be close to 0. Is it going to be exactly 0? No. Why is it not going to be exactly 0? Rounding 1. What else? Do we solve for exact roots, or do I solve for roots within some sort of tolerance? Within some sort of tolerance, right? We said we're going to allow for problem 2 0.01% error, so we're not going to get exactly a 0 value out of our root. We're going to get something really close, within 0.01%, but we're not going to get exactly the right, the perfect root. That's just kind of impossible to have. So any questions about that? Any other questions about root finding? All right, so now you have till the end of class. Yes, sir?
You go over the way we do it.
Sure. So the by hand problem, number 3, that's on your in-class exercise. So I'm not going to collect this, but I'm going to post the solution online so you guys can have it. So I've given you 2 initial guesses, right? I got those from my plot. What else am I going to fill in here? So let me see. I guess I could do it on the screen so everybody can see it. So what are those 2 x values? I've written this table in kind of generic form. I'm not using the variables that are specific to this problem. This is for the ladder problem. So what are those 2 x values? What do they represent in our ladder problem? The guesses for what? What variable?
For the W.
For the W. W is our root, so our initial guesses are potential values of W. In this case, that's the elevation of the crossing point. Or no, the distance between the walls. So this is these are in feet. So we guess and we say our root is somewhere between 35 and 39 feet. So now I need to get fx1 and fx2. Where do I get that stuff?
So you use this equation?
We use this equation. Which equation?
The
The zero equation.
To find the fx1.
To find fx1 and fx2. So fx1 and fx2 come from my zero equation. Once I've written my zero equation, it's a function, so I copy and paste my first line, I stick in 35 as my input to that zero function, and I get back out fx1 or fx2 depending on which one I gave it. Where does xm come from?
It's an equation. It's given to the method that you are using. For example, you are using the bisection, which is the bisection is x3 equal x1, then etc.
What is bisection method? What does that equation represent? It's xm is equal to x1 plus x2 divided by 2. What is that? The midpoint or the average, whatever you want to call it, right? That's what that formula is doing. So it's the average or the midpoint between these 2 points. So what's the average between 35 and 39? Hopefully we don't need a calculator for that. 37. So I put a 37 in here. And then where do I get fxm? From the zero equation. I take 37, I plug it into my zero equation, and I get an fxm value back. Then I determine what point I'm going to throw out based on what? The sign of what? The x's or the sign of the x's? fx's. So depending on if fxm has the same sign as fx1, I throw out x1. If fxm has the same sign as fx2, I throw out x2, right? And why is that? Because I always want to bracket my root. So if I go back over here to my drawing, I have, let's say, this is x1, this is x2, the midpoint, somewhere in between here, xm. Then I get my f values. This is fxm, this is fx2, this is fx1. So which point do I want to throw out? 1 or 2? 1, right? Because I got to have one x value on either side of my root. So if I throw out x2, I did something wrong, right? My root's not in between those 2 points. So I have to throw out this one, throw out that one, and this now becomes my new x1 point. Yes, sir?
Since there's the possibility of only every time going away, either your x1 or your x2, is that error in MATLAB that says that like after whatever might go unused, is that always going to show up?
So in your bisection method, you might get a warning that fx2 isn't being used. It's really not being used. We could get rid of that line of the code, but I kind of like to have it there just to remind me that's what I'm doing. So we can kind of ignore that at this point. Any questions about filling out this table? That make sense to everybody? All right, so take the rest of class. Do you have a question, Dave? Okay. Take the rest of class and see if you can finish this up. If you were done with this and you're done with your homework, then I will see you on Friday.